With the help of some examples, this video discusses how we find surface areas and volumes for three-dimensional objects. The surface area for z equals to f x y over the region D is given by this formula, where f subscript x squared is equal to partial f partial x squared, and f subscript y squared is equal to partial f partial y squared. Consider this example. You want to find the surface area of this paraboloid that lies inside the cylinder. This means we want to find this curved surface area that's within the cylinder. The intersection of the two surfaces is a circle. So the projection of the surface area on the xy plane is a solid circle. We call this region D. So we have the surface such that partial f partial x is 2x and partial f partial y is 2y. So the surface area is given by this formula. Let's look at the region D on the xy plane. Since it's enclosed by the circle x squared plus y squared equals 1, the radius is 1. If we let r be the radius, we can write D as follows: r between 0 and 1, and theta the angle between 0 and 2 pi radians. The surface area was given as before. Rewriting this in terms of r and theta, we notice that x squared plus y squared is r squared. Therefore we have, where dA is r dr d theta, for r going from 0 to 1 and theta from 0 to 2 pi. Integrating with respect to r, we get this. Which simplifies to finally integrating this, we get, which is approximately 5.3304 units squared. This is the formula for the volume of the solid bounded between the surface U and the surface V. In this formula, V is the upper surface and U is the lower surface. In this problem, we calculate the volume of the solid enclosed by the sphere and a cone. From the diagram, the sphere is the upper surface and the cone is the lower surface. The intersection of these two surfaces is a circle. So the projection onto the xy plane is a solid circle. Let's call this D. So the volume of the solid enclosed is a double integral over the region D, and taking the z expression of the upper surface, which is a sphere, or square root of 1 minus brackets x squared plus y squared minus the cone, which is square root of x squared plus y squared dA. We need to do some working to find the circle expression for the region D. This is found by solving the two equations. By substituting equation 2 in 1, we get this. Therefore, the circle is represented by x squared plus y squared equals to half. The region D on the xy plane is this. Since it's enclosed by the circle x squared plus y squared equals to half, the radius of the outer circle is 1 over square root 2. If we let the radius be r, we can write the region D as follows. R between 0 and 1 over square root 2, and theta between 0 and 2 pi radians. Let's get the volume formula from the previous slide. X squared plus y squared is r squared. And dA can be replaced by r dr d theta. So we can rewrite this integral in terms of r and theta, where r goes from 0 to 1 over square root 2, and theta goes from 0 to 2 pi. Integrating with respect to r, we get this. Simplifying, we get or 2 minus square root 2 pi over 3, which is approximately 0.6134 units cubed.